Hello, my name is Tony Shockey. I'm the North American Sales Manager with Sherborne Sensors, here to give you a company overview. So let's get started. So who are we? We're headquartered in what they call Transducer Valley in Basingstoke, UK, about an hour outside of London. We design, manufacture high-precision accelerometers, inclinometers or tilt sensors, and load cells. Been a market leader for years and years in both product quality and after-sales service and support, and offering a best-in-class 2-year warranty. We have products used across a wide variety of applications. We'll get into those here in a bit, but aerospace, industry, civil engineering, nuclear being some of those. Established global customer base with active customers in over 47 countries currently, and we were originally known as Shavits or Shavits Engineering. We achieved AS 9100 Rev D accreditation, which includes all ISO 9001 quality management system requirements and specifies additional requirements for us to be able to call ourselves a supplier in the aerospace industry. Pretty exciting for us. So as we look at the product offering from Sherborne, accelerometers is a big portion of this, so it's kind of a three-legged beast here. And we've got accelerometers. These are designed to measure the rate of change of velocity. We offer Servo as well as MEMS technology, and we'll go over that in just a little bit. We also offer inclinometers or tilt sensors. So these are designed to measure the angle of an object with respect to the force of gravity. And then we also offer load cells or force transducers designed to measure shear, compression, and tension loads. So as we look at the technology from a servo standpoint, here you can see on the right-hand side we've got an actual diagram of the sensor. So the paddle, which is listed as A, which is the pendulous mass right here in the middle, it moves. So the movement is detected by the position sensor, which is B, right around here. And then a current is applied to the torque motor. So if we look at the torque motor here, a current is applied to that to get that pendulum mass to come back to its resting spot or its null point, and then that current across a resistor generates a voltage that's proportional to the sine of the tilt angle. That gives you your output. Some advantages of the servo sensors: they have the highest resolution sensors available, so accuracy, if that's something that's important, and it definitely is in space and aerospace and where you're calibrating components to these sensors, it's incredibly important. So they can also measure static inputs, unlike MEMS and piezo sensors as well. We talk about the MEMS technology here. So you can see the unit on the right-hand side there, how part of it's fixed, part of it's not, part of it's moving. So what's happening here is you're changing the capacitance between the solid, stable, fixed support versus the item that's moving, and then that's going to give you the tilt angle or force that's calculated from these measured capacitance. Okay, one of the advantages here, it's less expensive. Another one is it's much smaller. It can be fit onto a printed circuit board or a very small area when area is at a large need. We take a look at accelerometers. So we've got both servo and MEMS. You can see we've got a good lineup here, different sizes, different applications, different outputs, over 25 different variants. A unit can be modified to meet your specific application. And then the output range, mechanical housing, connections, so on and so forth, can be personalized for you and your specific application and or company. So we do that fairly regularly. When we talk about accelerometers, we have a number of applications. This is just a handful of them. So in the aerospace market, flight control, health monitoring, crash recorders, flight simulators, fatigue life monitoring is something across all vehicles, whether it's aerospace, space, rail, automotive. And then when it comes to structural health monitoring, things such as dams or bridges or buildings, whether they're historic or skyscrapers. Those are some good applications. Also, if you're looking for low frequency analysis, you're not going to get it done with some other technologies, but we're definitely going to be able to do that with Servo here. and then a couple of others here with ejector seats and rocket platforms, so on and so forth. When we look at inclinometers from a servo standpoint, you can see the lineup that we have here. So depending upon your need, your footprint available, the connector that you're looking for, the conditions that it's in, whether you're looking for a voltage or a current output, a single or two channel. So if we look at a number of these are single axis sensors, and then you've got some dual axis options here as well with different connection points and types. You've also got the highest quality here with the largest ranges from plus or minus 1 degree to plus or minus 90 degrees and anything in between. There are some standards, of course, plus or minus 1, 14.5, 30, and 90 degrees are pretty common, but we can do anything in between there as well. And then these also have the highest reliability, accuracy, and repeatability amongst other sensors in this category. We talk about digital and MEMS here. So from a digital standpoint, we definitely have a digital output here on a single or dual axis inclinometer. It is gravity referenced, servo technology, and it does have the RS-485 ASCII digital output, something that's used in aerospace, aircraft, both civilian and other. And then from a wireless standpoint, we do have a wireless option. It is using MEMS technology. It is a single axis. And we do have either horizontal or vertical options with a 100-meter or typically 100-yard range. And that's to a handheld device and or a PC. And handheld devices can hold anywhere from 1 unit on up to dozens of units. Same with the PC. And then there is some included software to go along with that. Very easy to use. Inclinometer applications. So there's many. So you notice some of the vertical markets that we're looking at over here are the industries such as geotechnical, so platform, metal processing or metals in general, aerospace, mining and tunneling is a big application in the United States and North America. Test and measurement, research and development, so everybody is doing some form of research and development. There are great applications for these inclinometers to either be that test sensor in the R&D lab or to calibrate your other inclinometers to maybe that have lower application need from a quality standpoint, something like that. And then, of course, transport and civil engineering. So robots have become a great big deal. Most everybody's using them to some degree at any manufacturing plant. Big opportunity. Solar panel alignment, making sure that your solar panels are following the sun for those that actually move with the sun. Radar dish monitoring, you're following exactly what you're looking for. You need both one on the X and Y axis typically. Continuous metals casting is a huge application for us. And then once again here, measurement in calibration labs. Overhead cranes, both the kind in buildings as well as they're using for erecting skyscrapers and large buildings. And then here you can see heavy construction, farm equipment, road surface grading. You want to have very precise angles for runoff and other. And then in the rail industry, construction, monitoring, maintenance, all a part of applications that you can use inclinometers for. Both in ship barge leveling, so they need to know where they're at as well, so they're not listing in any direction. And then geophysical, a number of applications there. And then a few other applications here, such as horizontal pumps and critical applications, low frequency applications, so on and so forth. We have a number of what we call impact reports, which is kind of a little bit like an application note, or a case study where you've got something that's happening within a facility, some of the challenges you might have, and then a potential solution. So a few good pieces of literature that we've got available for you if you're interested. And then we talk about load cells. We also have load cells, and the technology there is really around the Wheatstone bridge. So a Wheatstone bridge is nothing more than two simple series parallel arrangements of resistors connected between a voltage supply terminal and ground. They produce a zero voltage difference between the two parallel branches when they're balanced, and when they're not, they give you a value. So as you can see here in a couple of different applications, as you're applying the weight to the application on the left, you can see the null meter in the middle at 0 when balanced, and then when you add force to it, it gives you that output that's according to the sensor and the orientation. Very, very similar to this guy over here where you're going in both directions. You can see when you hit that medium point there, that null point, there's no output, but whether you go positive or negative, you're going to get the output based on the amount of force or weight that's being applied. We take a look at the different load cell types and some of the applications here. So we've got the compression type, a couple of options here with sensors, the shear type, and then we also have compression and tension. And then some of the applications with that. So if you're doing force testing, materials and fatigue testing, compression, high accuracy weighing, it's very common. And then in industries such as nuclear, automotive, and metals, there's a lot of applications out there for this type of application if you're looking for very precise measuring. And then of course, if you're looking for variations and modifications to maybe what you're currently doing and you need something that's more personalized, we have processes and infrastructure to modify, test, and deliver personalized inclinometers, accelerometers, and load cells. And then with the mainstream units that we have available, we can also personalize them based on the conduction type, the output range and type, mechanical housing, so on and so forth. And then if there's something that you would like more specifically for you, your brand on it, we can personalize that as well. We're looking at some of the vertical markets or industries. So heavy industry, that's a huge market for us, so a wide range of applications from fabrication to manufacturing to production in low frequency or other applications. And then inclinometers, load cells for us here, as well as accelerometers in the North American markets the need is growing on a regular basis, so we're finding more and more applications regularly, which is great for all. Aerospace industry, so we have a very strong presence in there. We do have the pedigree to work within the aerospace, which is great. Very few people have that. So a couple of key customers there that we're heavily entrenched with, but there are a lot of others. Established as a major provider in a variety of space programs, one in India specifically, where they're using our equipment for launching satellites and rockets into space, so inclination, very big for them. And then this is, we call it our second biggest market for Sherborne globally. So there is a big presence there of Sherborne within that vertical market. Talk about civil engineering, we're talking about structures, so dams, buildings, bridges. There's been a number of issues over the last decade or longer in North America. We've got solutions there to give you early indications of when failures may occur, and this could be critical for a number of different things. So significant growth area for us. And then we talk about transportation. So these are just four of the key large vertical markets or industries. So we work with any kind of transportation. So whether it is civil or otherwise, whether it's trucks, agricultural equipment, vehicles, cars, motorcycles, you name it. We've got the ability to work with that. A couple of others there, we're talking about rail and sea as well. So anywhere from yachts on up to very, very large vessels that are carrying people and or product from one location on the planet to another. It's a great opportunity to use our products. So if you look at the application overview, this is a small subset of that. I've highlighted some in darker font here. Robots, dams, bridges, structures, satellites, overhead cranes, rail line, ship, barge leveling, aircraft, space, micro-tunneling, all of that being very great opportunities for us to be able to assist customers in those markets to achieve their goals to the best of their ability. So great partnerships. Thank you for your time. If you guys have any more questions, feel free to reach out to Sherborne Sensors.